This demonstration will show the safe and proper use of controls on the Bridgeport milling machine. One of the first things when you walk up to the Bridgeport is to make sure that all of the locks are released so that everything is free. Your spindle is free, your table is free, your cross slide is free so that you can move the table in and out for setup work, and that your knee is free for up and down, so that you can move everything up and down without a bind someplace while you're setting up your work as you're getting ready to work. Next, we'll go through the oiling of the Bridgeport. Now, in oiling the Bridgeport, we have a little oiling cup up here, and we put a little shot of oil in there, a little shot of oil in the second cup on the right-hand side of the head. This oils down through the spindle and the bearing up there. And then we come down to the spindle itself, bring the spindle down, and put a shot of oil around there, and wipe it around with your finger, and run the spindle up and down a couple times. This gives you oil up into the lower part of this casting or housing there. And move across, oil a shot of oil across the ways. Now this doesn't oil underneath the table, but it gets the felt, the wiper, oiled, and that helps flush the chips ahead of the table as you're moving the table on the knee. And same down behind here. Give it a shot of oil down behind here on the ways and on the vertical ways going up the column. Give it a shot of oil there. They need a lot of oil, and it helps protect them and so on. Now, if you have cast iron, you must be extremely careful that cast iron is kept, the machine is kept clean from cast iron shavings. Now, we have 2 cans of oil here, cutting oil and lubricating oil. And we use the lubricating oil for lubricating, and the cutting oil, which is orange can here, the orange can, that's used only for adding to around the cutter itself, if you're threading, boring, some job that you need it. Lubricating oil for lubricating. The last lubricating spot we got on this machine is down behind here. We have a plunger, a little tank down there, a spring-loaded plunger, and we push the plunger down, and as the plunger is coming up, it oils up the tubes bring the oil up to the bottom of the table, so it gets the ways oil up underneath here, and gets the across the gibs and so on in here, and the movable parts, gets them oiled up. Next, we go to squaring the head. Bring the head, or spindle part of the head here, bring the spindle all the way down, and we got to make sure that the head is square with the table. It must be square with the table. Now, for general purpose work, we'll take a feeler gauge and we'll move the table, line it up with the head, and drop it a little bit here. And it'd be a good idea here, you lock your knee, and now you're ready to check. And you shouldn't be able to put the feeler in here. It should be straight enough up and down here in the 5-inch of travel that be square. And that's for longitudinally here. And then for the cross here, you'd come in again, and you shouldn't be able to put the feeler in there. Then your head is satisfactory for most all of your general purpose work. Now, if you're doing a more precise work, then you would go to an indicator, and you'd put an indicator in here, and you'd indicate around here, and then you'd swing it around. It's on a rod, comes out with a clamp, and you'd swing it around, and you should read the same on both sides. And then, of course, you'd swing the indicator over here and over here, and that would indicate your table. Now, here on the chart we have showing the front view here of the machine, and this is longitudinal, getting your table indicated. And when the indicator would be here, you'd set the dial, and then you'd swing it 180 degrees, or swing it around to the other end of the table here, and check it here. Now, when you had the head, these 4 bolts here, loosened and set, when you had them correct for tilt, then your table, your head would be square with the table in this manner. Now, to get the cross slide squared away, we have 3 bolts up here on the side of the mill, which would be just slightly loosened, and then the screw is turned slightly, and that way you can adjust so that your head is square with the cross slide movement of the milling machine, with the knee here, and get the same reading on your indicators there to show that you're trued up there, and then tighten the 3 bolts up there. That would take care of the head. Then next we would go on to the spindle, and we would want to, if we can pick up here on the high range and low range switch. Now, on Bridgeport, they say high range, low range. And these run two different directions. So as a result, we have to be careful which way we're running this. I would prefer that you think of it on, off, on. Now, on, off, and on again. Now, we'll mount a cutter in here and show you the rotation direction here. And we'll show our speeds, changing of the speeds here and so on in here. Pull up the drawbar nut, hold the brake, pull up the drawbar nut, snug. And now we have our off-on switch, and we've got it in low range right now, and we want to see that we're going in the correct direction. Now we can vary our speed by changing the speed up front here, the dial up front. Now you'll notice here, we have it right on here taped. Do not change speeds unless motor is running. Do not change speeds unless motor is running, right in front of you. Stop and read that once in a while. Don't change this unless your motor is running. Now, we'll show we're setting on about 100, and we can screw it on up here to some speed. If we were working in aluminum on this cutter, we might be running perhaps 300 RPM, and if we were working in cast iron, we might be running maybe 50 or 60 RPM or something like that. That's as slow as it goes. Now we have direct drive and back gear, and we'll pull it all forward into direct drive. Right here you can see that direct is high, neutral, and low. And now we're in high, and again we can check the rotation, make sure it's going the right way. So you might be rotating the wrong way. Watch the cutter. You can see it when you stop the cutter. You won't be able to see it when you start, but you can see it when you stop the cutter. You can see the rotation. Then we can speed it up again for, if we had a smaller cutter in, we might want it to run quite fast, and we can speed it up and vary it. Vari-speed drive in here. Use it, turn it only when the motor is running. Now, we do have neutral here. I mentioned that neutral, high, low, neutral, and that way you can turn the cutter here freely. The spindle is free now for neutral. You can put an indicator in here and indicate into a hole that you might be working on a boring job or something like that, and then put it back in the gear that you want, either back gear or direct drive. Next, we'll go on to the automatically I was using the spindle brake, and we have a brake up here, and don't ever leave the brake on. Sometimes people will pull them out and lock them when they're changing or something. Be sure the brake is off. Just use it to stop the machine immediately. Turn it off. Don't leave it on. Then we'll move on to our quill engage and disengage and our hand feed here. Now we've got this fast lever for moving up and down. The hand lever here for moving up and down the quill. And we can position this in different positions for being handy for our work. It's free here. There's a groove here, and it's a little sticky there. Little groove here, and a whole bunch of holes in here, so that you can position this where you would like to position it for your work. If you wanted to work here, or if you wanted to work here. It's pretty clumsy back here, so probably you'd snap this out and change it around over here, and then you could work in this range of work. It's nice to keep the handle where it's kind of handy. Now, we have manual feed on here that we use. We have a button up in here, and the button is in neutral position. And then we have a clutch here. Neutral position, hand wheel is free. And now we throw the clutch here, and now we're turning it down manually. We're turning it down manually. Now it's free. It doesn't move it. We're free here. We can move this up and down. Now we can move this up and down here. This is manual feed. And for precision drilling, something like that, where we want to do it by hand and not crowd the cutter or something, why, then we can feed this up and down for certain types of work. Maybe starting a hole or something like that. This is for general drilling or something like that. We might use this. Next, we have automatic feeds on here. We have a little gear case up here, Quill feed, and we have disengage and we have engage. And leave it parked in disengage when we're not using it. We engage it when we're going to use automatic feed on the head. Engage it for automatic feed on the head. And now our head, as we turn the machine on here, and we push this button in. Now it's turning, but it's not moving down. Now we pull the clutch. Now we're moving down. Now this turns all the time until you pull this into neutral. Now it's free. Now we're in neutral. There. Now we pull this out, pull the clutch, and we're going up. I'm sure it catches in there. Doesn't always catch. And back to neutral with this again. Now next we'll show we have stops on here. We have a micrometer stop that we can set our depth that we want to go to. We can rotate this upward, and if we have some particular depth, we'll set it at 0 here. And if we have some particular depth that we want to stop at, it'll stop at the same spot, same depth each time. Once we've found out where we want to go to or something like that, then we'll stop the same step. Now here's the way this can work. We can use it like we're drilling to a certain depth, or if we're boring to a certain depth. And it'll rotate down, and it'll automatically stop the quill going down. Now the quill keeps this rotation, and if you left it in the hole and didn't get it out of there, it would naturally burn your cutter from continuous rotation. But it goes down and stops its depth. Now, one to go 20 thousandths deeper. If that weren't quite deep enough, you checked your work, it wasn't deep enough, you could move this 20 thousandths, lock the dial. You could move it 1 thousandths, 5 thousandths, 20, 50 thousandths. It's 50 thousandths per revolution. So you can move it 20 thousandths and continue on down, and this would go 20 thousandths deeper and shut off again at that depth. Now, by the same token, if you're going up for some reason here, and it shuts off automatically as you're going up, so you do have stop at the top and stop at the bottom, but our micrometer stop is for depth. And always put this in neutral again. We have in, neutral, and out on this quill feed direction here. Down and up and neutral. Then taking care of the depth setting and so on, and so now we can move on. We do have the quill lock right here that we quite often will lock our quill when we have it at a certain spot. Might be, for instance, we might go down in to cut a depth into something, and then we want the table to move. So we lock the quill, and perhaps our cutter will go across the piece or down into a piece and go machining the path. Might be the bottom of a cutter groove, something like that. And then when we reach the point that we want it, we release this and pull this back out again. So we can lock our quill for general machining, surface type machining, or depth to a certain depth. And release it again and race it out. Now we have table feeds next. And we have left and right, and we have the off-on. Down here, Bridgeport's got a solid state control, and instead of using belts to change belts or a gear case, they have a solid state. They have an off-on switch. And with this off-on switch, when it's up, it's on. There's a little red light. The little red light tells you that the automatic feed is ready to go. All you got to do is hit automatic feed, and you're going. And it's independent of the head. The head doesn't have to run. Now, this has a nice feature for setup. You don't have to run the mill for setup. You can use it for setting up, and you don't have to run it. But remember one thing. If your cutter is not running and the table is running, obviously you would bend the head out of shape or you'd bust the cutter, something like that. So the head must be stopped before the table is stopped when you're using the two in conjunction for machining. Now, we have a rate of feed in here. We have marked on here 3/4 up to 30 inches of feed. So we can move along at 3/4 of an inch per minute, and we can move on up to 30 inches per minute. For some extremely fast work, if you're working in some Teflon, something like that, something soft machining. And cast iron would be very slow. We might slow it down to as low as 3/8, and it's kind of a guessing game. Anything below 75, 3/4 of an inch here, 0.75 is kind of a guessing game. But now we have rapid traverse. We push the button, rapid traverse. It's an overriding winding on the motor, and it's used for setup work. It's not, rapid traverse is not used for machining. It is only used for setup work. You want to move the table quickly. It beats turning the crank by hand for general work. You move up close to the work, and then the last ½ inch you move by hand. So you move rapid traverse close to the work, and then the last ½ inch move by hand when you're going into your work. And direction, if you're going to the left, the table moves left. If you're going to the right, the table moves to the right. Now we have the knobs on the end here. We can loosen the lock nut, and we can spin the dial for some particular setup here. Wherever we might happen to want the dial, usually we set up like indicating into a piece or something. We loosen it and set the dial and bring ourselves back to a 0 setting, something like that. And each one of the knobs has that. The cross slide has it, the longitudinal has it, and the vertical has this. Now, we don't have automatic feed on the cross slide. Cross slide is moved by hand. We have the crank here just to crank it by hand. And if you want to know how fast you're cranking, supposing you're feeding 1 inch per minute, then set the table for a 1 inch feed and look at the crank on the longitudinal. That'll give you a pretty good idea. You could look at the clock and approximate it and explore it, but if you look at this and then come back, it's rotating at about a certain speed, so you could rotate your cross slide at about the same rate, and you'd be traveling at about 1 inch per minute. If you travel too fast, you break the cutters. You travel too slow, you rub them to death. So you want a reasonable rate of feed that's not too fast, not too slow, and it's what your cutter is calculated at. Up and down, we have the up and down of the table. Turn it up and down here, and the knee crank here for going up and down. Incidentally, the knee crank here, quite often we want it out of our way, but we got to watch out. The knee crank can be broken awfully easy. If you don't engage the teeth thoroughly, they have a tendency right high on the outside, and they chip off. A second feature with the crank here, it's common. These are cast iron. They fall on the floor, and as a result, they break. And you can see here's one that's been welded up. It seems like they never really work so good, and they don't look so good after they're... here's one that's got a couple teeth broke out of it because it's not been engaged properly. Take a look with your eyeballs there and make sure you engage that thing and get it properly engaged. Don't ride it half out so that it has tendency to slip out. Make sure it's engaged. The last part that we'd probably cover in here will be the ram movement. We move the ram forward and back over our work. We might have a big chunk that requires us to get out a ways here, and so we might have to move the ram forward. And we loosen the lock on the ways, and then we can pull the ram forward. We can shift it around. Now, be sure they're loose. Now we can swing the ram forward. It's a little heavy. Makes you snort a little bit. And we can move it forward, and we can move it back. Most of the time we run it in the middle. But if we need it forward or back, Bridgeport offers the opportunity of having it in those positions. Now we have some other bolts on here too, and therefore if you want to swing it like a turret, we can loosen the other bolts. There's 2 here for the ram movement. Now we have 4 vertical bolts, and we loosened the 2 here, and then the 2 on the back side, over on the other side. We loosened those 4 bolts, and we can swivel the whole turret top here. We can swivel the top so many degrees if we want out for certain type of work. Maybe we want to make some type of machining out this way or something like that. We can do that, or we can come out here and we can machine over in this spot. We can have another setup over there, and we can swing the head over there and machine that and not interfere with each other on certain types of work. And, of course, be sure that you tighten the bolts down securely when you finish the work there. And the good habit is to store the crank or the wrench up here where you get it out of your way, but still right-handy for usage, because quite often you want to use the wrench again for taking the cutter out. And it's very handy here to be able to take the cutter and remove the cutter from the spindle. Loosen it one turn, and use a soft-faced hammer to tap it loose. Just one turn on the knockout bar and loosen it. And if you have a very sharp cutter, it would be, if you're working around a vise or something, it'd be a good idea to use a rag to hold it, because when it comes down and breaks loose, it's somewhat handy, and if you drop your hand into something, you can perforate your skin or palm very, very easily with the sharp cutter. That pretty well covers the Bridgeport mill. We have the off-on switch, and watch your rotation direction. Off-on switch, watch your rotation. When you're varying the speed, be sure that the motor is running to change the speed. Be sure the motor is running to vary the speed. Leave the direction here, the down feed gear case here, leave it in disengage. You have engage and disengage. Leave that in disengage, and release all of your locks when you're finished, so that you won't have any bind on there. The next fellow won't be binding up and so on. And that about covers the Bridgeport mill.
The preceding materials are copyrighted by the Chippewa Valley Technical College, Eau Claire, Wisconsin. Duplication of these materials is strictly prohibited. Infringement may result in penalties ranging from fines to imprisonment.